Welcome to learning about AI knowledge graphs. Today, we'll explore how artificial intelligence makes sense of complex information by connecting the dots between real world things. Imagine if your computer didn't just see words on a page, but actually understood how people, places, and events are related. That's exactly what a knowledge graph enables. From finding the right movie to getting accurate answers from Alexa, this technology powers many smart tools we use every day. We'll start from the very basics, using simple metaphors and real life examples, so no prior deep tech knowledge is needed. By the end, you'll not only understand what a knowledge graph is, but also how to build your own mini version. Let's dive in and uncover how machines learn to think more like humans. This journey begins with understanding how facts are not isolated, but deeply interconnected. Now that we've begun, let's take a quick tour of where we're headed in this session. First, we'll answer the question, what exactly is a knowledge graph? We'll use everyday analogies so it clicks immediately. Then we'll dive into the core building blocks, entities, and relationships, and see how they're like the nouns and verbs of machine understanding. Next, you'll learn about triples, which are the simplest way to express facts in a structured format. After that, we'll look at real world applications like how Google search or voice assistants use these graphs to give smart answers. Finally, we'll wrap up with hands on practice ideas and a clear path for what to explore next. This journey is designed to be clear, engaging, and practical. By the end, you'll have both a theory and a confidence to start seeing the world through the lens of connected knowledge. Let's get started with the big picture. Now let's understand what a knowledge graph really is. Simply put, it's like a digital mind map that connects real world things, people, places, events, objects, and shows how they're related. It's not just a diagram. It's a structured way for computers to store and process knowledge. For example, instead of just knowing that Albert Einstein exists, a machine with a knowledge graph knows he was born in Germany, developed the theory of relativity, and worked at Princeton University. These connections turn isolated facts into meaningful knowledge. Let's take Google search as a real life example. When you search for Leonardo da Vinci, Google doesn't just return web pages, it shows a panel with his birth date, famous artworks, and even links to related historical figures. That's powered by Google's Knowledge Graph, which organizes millions of facts into a web of understanding. Similarly, when Amazon suggests products, it's using a knowledge graph to see patterns, like how people who bought a camera also bought a tripod. So, a knowledge graph doesn't just store what things are, it stores how they're connected. This is what makes AI systems smarter than simple keyword matchers. Let's now break down the two essential ingredients of any knowledge graph: entities and relationships. Think of entities as the nouns, the main things in the world. These could be people like Marie Curie, places like Paris, or even abstract ideas like radioactivity. Relationships of verbs, the actions or links between these things. For example, worked on, lives in, or is capital of. Picture a photo album where each photo is an entity and the caption explains its relationship to something else. When you combine them, you create meaningful knowledge. Here's a key rule: every fact must have at least two entities and one relationship. For instance, saying Tom Hanks isn't enough, it's when we say Tom Hanks starred in Forrest Gump that the machine gains real understanding. In healthcare, this logic helps systems know that diabetes is treated by insulin, a simple but powerful connection. The beauty of this system is that it scales. Once you have many such connections, the AI can start making inferences, like realizing that a drug used for one condition might help another related disease. So, entities and relationships are not just data, they're the very foundation of machine reasoning. Let's now see how these pairs are structured in a standard format. Now let's look at how facts are actually stored in a knowledge graph. The triple. A triple is simply a structured fact made of three parts: subject, predicate, object. Think of it like a tiny sentence. For example, Earth orbits the Sun becomes the triple. Earth orbits Sun. The subject is what we're talking about, the predicate is the relationship, and the object is what it's connected to. This format is powerful because it's both human readable and machine friendly. Each triple is a single piece of knowledge, and when you collect many of them, they form a web of understanding. For instance, Paris is the capital of France, tells a computer something specific and clear. Similarly, coffee is served in mug, helps a smart home device know how to respond when you say, I need a new coffee mug. What makes triples especially useful is that they can be linked. If you know Marie Curie worked on radioactivity, and radioactivity is used in cancer treatment, the system can infer that Marie Curie's work is indirectly related to cancer treatment, even if that exact fact isn't stored. This ability to chain facts together is what gives knowledge graphs their intelligence. So triples are like building blocks, small, simple, but incredibly powerful when connected. Now we're ready to explore the magic of knowledge graphs, not just storing facts, but making them work together. Imagine you know two simple things. First, that Marie Curie worked on radioactivity, and second, that radioactivity is used in cancer treatment. Even if no one told the system that Marie Curie is linked to medicine, it can still make the logical connection. This is called inference, the ability to derive new knowledge from existing facts. Traditional databases can't do this well because they store data in flat tables, but a knowledge graph creates a network where each fact is a stepping stone to another. This is why AI systems can answer complex questions with ease. But there's a catch: the quality of the graph matters. If one triple says NYC, another says New York, and another says the Big Apple, the system might think they're different places. So, best practice is to use consistent names, always New York City, and clear, standardized relationships. This ensures the machine can reliably follow the connections. Think of it like giving someone directions. If street names keep changing, they'll get lost. But with clear, consistent labels, they can navigate smoothly. So, a high quality knowledge graph doesn't just have more data, it has better connected, well structured data that supports true reasoning. Let's now see how knowledge graphs power real world AI tools you use every day. First, consider search engines. When you type, "Who is the CEO of Tesla?" Google doesn't scan every web page for that phrase. Instead, it checks its knowledge graph for the triple: Tesla has CEO, Elon Musk, and gives you the answer instantly. That's why you often see a knowledge panel on the right side of the search results. Next, think about voice assistants like Alexa or Google Assistant. If you say, "Play movies with Tom Hanks," the device knows Tom Hanks is an actor and looks for movies where the relationship starred in links him to a film. It doesn't just search for the words, it understands the role. This is only possible because of the structured relationships in a knowledge graph. Another powerful use is in recommendation systems. On Amazon or Netflix, when you see "you might also like," it's because the system has built a graph of what users like, what products are similar, and how things are related. Even in healthcare, knowledge graphs help doctors by linking symptoms to diseases to treatments. The same principle applies across industries. If a system needs to understand context, it likely uses a graph. So, this isn't just a Google thing, it's a fundamental AI tool used in many smart applications. Let's take a moment to review what we've learned so far. First, a knowledge graph is not just a diagram, it's a structured network that connects real world entities like people, places, and events through meaningful relationships. Second, it stores information using triples, subject, predicate, object, simple sentence like facts that machines can easily process. Third, entities are the nouns of the system, like Tom Hanks or Inception, while relationships are the verbs that link them, such as starred or directed. Fourth, when these triples are linked together, the system can go beyond storage and actually reason making logical inferences, like connecting Marie Curie's work to cancer treatment. And finally, this technology is already all around us in Google search and voice assistants, in product recommendations. You now have the mental model to understand how AI systems make sense of the world, not by memorizing, but by connecting knowledge. These concepts form the foundation of more advanced AI topics like natural language processing and semantic search. If you can explain these 5 points in your own words, you've truly grasped the essentials. Now it's your turn to apply what you've learned. Now it's your turn to apply what you've learned. Apply. Let's do a few quick exercises to reinforce your understanding. First, pick your favorite movie and write 5 triples about it. For example, you could write Avatar, director James Cameron, or Dune, based on novel. Make sure each triple has a subject, predicate, and object. Next, try building a small knowledge graph with 3 people, maybe friends or family, and connect them with their jobs and cities they live in. For instance, Alice works at hospital. Alice lives in Chicago. You'll see how easily facts start to link. For a bigger challenge, sketch a family graph using relationships like parent of, sibling of, or lives with. Use paper or a whiteboard to draw the connections. As you do this, notice how structured knowledge gives you a clearer picture than just listing facts. These exercises aren't just academic, they mirror how real AI systems are built. And if you want to keep practicing daily, try turning news headlines into triples. For example, scientists discover new planet becomes scientists discovered new planet. This habit will sharpen your ability to see the world in connected terms. Congratulations! You've just completed a solid introduction to AI knowledge graphs. You now understand how machines go beyond keywords to grasp meaning through connected knowledge. You can define entities and relationships, structure facts as triples, and recognize how this technology powers tools like Google Search and Alexa. You've also practiced building your own mini graphs, giving you hands-on experience with the foundations of a reasoning. But your learning doesn't stop here. If you're curious, consider exploring ontologies frameworks that standardize how entities and relationships are defined across large systems. Or dive into natural language processing, where I learns to extract triples automatically from news articles and books. Another great next step is learning about graph databases like Neo4j, which are designed to store and query knowledge graphs efficiently. You can even join online communities like artificial or AI forums to discuss real world use cases. Keep practicing by turning everyday information into structured facts. The more you do it, the more you'll start seeing the world as a web of connections, just like an eye does. Thank you for learning with me and keep exploring.